and it ensures that the data transmit from source to destination.
Yes, primary function of transport layer is providing layer 4 information, you can say.
Yes.
Port number is also known as by layer 4 information. And what is the primary function of network layer?
Sir, provide IP address and routing.
Providing IP addresses.
Hmm.
And what is the primary function of data link layer?
Sir, providing hardware address.
Okay. And physical layer?
Delivering the bits converted to
Yeah, into signal, bits into signal, into light signal, into electrical signal, or detecting the link, that link is working fine or not. Okay. What is encapsulation?
encapsulation means data is going to maintenance layer to physical layer.
Okay. Decapsulation?
Going to foundation layer to application layer.
Okay. Very good. Encapsulation means adding extra information with data, and decapsulation means removing extra information from data.
Data.
And how does data move through the OSI model layers during the process of communication? Okay. After finishing of the OSI model, again we can discuss this question. What is the significance of data link layer in OSI model? Providing okay layer 2 information. Then which layer of OSI model is responsible for logical addressing such as IP addresses?
Network layer.
Network layer. What is the role of transport layer in OSI model and what protocol operate at this layer?
Provide
Port address and TCP UDP.
TCP UDP. Very good. Describe the function of network layer. Okay. Function of network layer, again providing logical address. What is flow control?
Like before communication, some negotiation happened between person.
Which layer is
which
responsible for flow control?
flow control means sir, provide the acknowledgement.
W-
Transport layer.
In transport layer only it will happen, that flow control.
Yeah, transport layer. In transport layer, there are some flags. Prem, there are 8 flag, but 6 flag are in use, and six and last 2 flag is one is CWR flag, that is congestion window reduced flag, and you don't need to read these 2 flag right in CCNA and CCNP. But again, I am telling you, this flag is used for congestion, network congestion, and the last flag is ECE flag. ECE.
Oh
ECE
yeah, yeah.
stand for EC.
Explicit congestion notification.
Yes.
Thank you, sir. Thank you so much.
What is the use of SYN flag?
Scene place are making a connection.
To start the connection.
Which connection?
TCP connection.
TCP connection. Very good. Okay, what is the use of
TCP
uh,
connection.
okay, TCP connection? To stabilize TCP connection, we can say, right? Okay, the next flag is like SYN ACK flag.
Uh, provide the acknowledgement.
Acknowledgement, yes, it is used for acknowledgement. And FIN flag,
Sir, finish the connection.
finish the connection. And reset flag,
Sir, reset flag.
Abnormally disconnect the connections. Like center, they will not be aware, and
why
that's in the
machine will
middle of
send reset flag?
If
like
ACK is not received,
No, no.
no. Some network congestion or something happens in the network. Something goes down
No,
like
if
wrong.
particular service is not enabled, let's say I have received one SYN message and their destination port is 23 or 53 and DNS is not enabled on that server, then server will send what? Reset flag. Let's say here I have one computer and this is server. On this server we are running some services like DHCP. We are running services like HTTP. two services running on the server, and IP address of this server is 10.1.1.2. IP address of this machine is, let's say, 10.1.1.1. okay, and this machine need, you know, IP address for a particular domain name. For www.google.com, this machine need IP address. So this machine is going to send what? DNS query message to server, to this server. Let's say it is going to send query message. Here you have defined the DNS server IP address is 10.1.1.2. so definitely machine is going to ask what is the IP address of this domain name to 10.1.1.2. okay, so it will send which message first? DNS is TCP based or UDP based?
UDP.
UDP.
UDP based. So it will send what message of, sorry, DNS request message. And when this server will receive this DNS request message, at layer 4 it will came to know that this is a request for DNS. At layer 3 it will check only IP address. Destination IP is 10.1.1.2. okay, this is my IP address, so it can traffic can be for me. But at layer 4 it will came to know that no, DNS service is not enabled, right? We are not running the particular service for port number 53. Then this server will send what? Reset message. okay, and even if this machine is sending SYN message with, let's say, destination is 23, any port number which is not with that service is not enabled on server, and whenever the server will receive SYN message for that port number, it will send reset message. After that, next flag is push flag. So yes, can anyone tell me what is the use of push flag?
Like giving the priority, so to send immediately from the list of packets, like giving some priority to some specific packets to like immediately reach to the destination.
Okay, there
No,
is one
actually,
more
that
flag.
is urgent. That is urgent flag. That one.
Yes, that is urgent flag. Can anyone tell me the difference between urgent flag and push flag?
No, that urgent flag actually depends on
Both
the
the same,
priority.
like,
The data will be the data will be delivered.
Sorry, can
Hello.
you speak again, brother?
Based on that priority, the data will be sent from the source to destination. Actually, based on the priority, that urgent flag will be worked on that.
no, actually
What
both
is-
the same. In the case of urgent flag, it will not maintain the sequence, and in the case of push flag, it will maintain the sequence.
It will maintain the sequence. I'm not getting.
Yeah, like there are
Yes.
say 10 packets, so sequentially it will set in the case of push, and
Always keep
in
in
the
mind one thing, that whenever any device will receive traffic, first of all, it will put the traffic packets in buffer memory. Let's say this is server and the server is receiving some packets. Packet like this, let's say packet, and here let's say on this packet push flag is on. So what will happen with this packet? This server have received these packet, and out of these packet, one packet have push flag on. This is the buffer memory. Will this server install this packet in buffer memory? No. It will
No, it
directly
will
process
directly
this
send.
data.
Yeah.
It will directly process the data. And if urgent flag is on, let's say on this, urgent flag is on. Urgent flag is on over here. So what will happen? It will put this data in the first, in the sequence. In the buffer memory, it will put this data on the first. First machine is going to process this data, after that this packet. So if urgent flag on packet received by a device, device will put that packet in first in the sequence. And if server will receive a urgent flag on packet, it will not put that packet in buffer memory directly, it will process the data. This is the only difference. Okay.
Prabhuji, can you come again? Sorry.
Yeah, what I am saying that if push flag is on with one packet, push flag,
Okay.
then
Okay.
server or any device will process that data directly. It will not, put that data in the buffer memory. By default behavior is first it will put the data in buffer memory. When buffer memory will get full, after that server will process the data.
Yes. Yes. Okay.
Right? If urgent flag is on, then it will put that data in first in the sequence in the buffer memory.
Okay. Okay.
Okay, let's say there are some data. This is sequence number of this data is 1, 2, 3, 4, 5 and 6 in the buffer memory, and there is one packet where urgent flag is on, so it will put this data over here, sequence number 1, and this packet sequence number will become 2, 3, 4, 5 like this.
Okay. Okay.
Okay, so this is a small difference between push and urgent. Both are used for quality of service. Both are used
Means
to send the data urgently.
okay.
Yeah.
Means that when the push will be on, that data will not be stored in that buffer memory.
Exactly.
It will directly deliver, right?
Right.
Okay.
Directly processed by machine. Machine never put
Yeah.
push bits on packet in their buffer memory. Any devices does not, you can say, put push bits on packet in their buffer memory. Okay, पुश बिट अगर ऑन होके कोई पैकेट आया तो डिवाइस उसको कभी भी बफर मेमोरी में डालेगा ही नहीं. डन.
Okay. Okay. And one more thing here, that urgent bit, then actually how it will take, actually we have to do that manually, or actually how it will understand this data is urgent.
This is part of application. At application you are generating, depends on your application. It depends on your application. Let's say here is one application and here you have another application. Whenever your application will communicate, here you will have lots of devices, right? It depends on your application, that how your application is generating the data. Maybe your application is going to generate the data with push flag on or urgent flag on. These devices, router and switches, are not going to use this flag. That's why you don't need to learn these things in detail. I was thinking to skip this part.
Okay, means application means actually depends on that service only, right?
Yes, exactly.
Okay.
Like on a server, let's say we have hosted one application. Okay, so generating data is completely depends on our application, that how you have designed the application and how you are generating the data. Like when you are pinging, when I am pinging to IP address, I have multiple options. Directly I can ping to IP address, I can set the size, I can set the repeat count with the packets. That means what I am generating ICMP traffic, but I can generate ICMP traffic with size also, with repeat count also, like this. Done.
Sarji, could you please use the background as a white color, because it is a little difficult to see.
How to change it? You know it. Here
Sir,
it is.
change the color of pen. Use the yellow color.
Is it visible now?
Yeah. Yes.
Yeah, and the color, pen color is little bold.
Black.
Okay, this one. See
Black,
this one?
better. Okay.
Yeah.
Black.
Black.
Yeah, this is okay.
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 Yeah, that is fine. Yeah.
Which one is fine? This one or this one?
Second one.
Second one. Okay. So can I move, guys? Tell me. So TCP header, you now you are familiar with each field of TCP header: source port, destination port, sequence number, acknowledgement number, header length, reserve field, flag, window size, checksum, and urgent point. Fine. After that, here you can read each field also. Then you have UDP header. In UDP header, there is only source port, destination port, header length, and checksum. After that, your data. After that, we have IP header.
Recording. You just start recording.
Yeah.
It's over. Okay.
Then IP header. In IP header, there will be information about version. That which version of
Sir,
IP.
one question, sir.
Yeah.
Sir, TCP UDP header.
Okay.
Sir, here is 1, 2, 3, 3 parts, sir.
3 part means
Sir, use here 4, 8 to 12 bytes, sir.
12 bytes means
That means, sir, here is 5 field, no?
64 bits.
नहीं जैसे कि 32 बिट है तो
Yes.
इन
32
सब
plus
का
32, 64.
ओके ओके
Total size of UDP header is by default. This is by default size. Minimum
Okay.
size will be 64 bits. Means
Total-
8 byte. This
टोटल
is-
8 बाइट
Yes, this is one advantage of UDP also, right? TCP is going to add 20 bytes extra information, and UDP is going to add only 8 bytes extra information.
ओके सर ओके
Okay, so if someone will ask you what is the advantage of UDP over TCP, you can say first advantage is this is fast as compared to TCP. Second advantage you can say is header size.
8 बाइट
If header size is less, then that means size of segment can be large. Yes or no? If
Yes,
we are using UDP and a router can transfer only 1500 bytes of data at a time, so here at transport layer we are using only 8 bytes information. At network layer we are using 20 bytes information. So size of data can be, size of segment can be
इंक्रीज
increase. Yes, getting my point. So this is one another advantage of UDP.
ओके
Okay, after that, here in IP header, guys, if I will talk about the important field, so see there are some very important field like TTL, time to live, protocol, source IP, destination IP. These 4 fields are very important. These 4 fields are very important. You have to understand each field, right? Source port, source IP, and destination IP is easy. We all know this will be the IP address of sender device. This will be the IP address of receiver device. Why we have protocol field? Anyone have knowledge about this protocol field? Hello.
Like what are the protocols are used by upper layer, like ICMP 1 or TCP 6 or UDP 17, so that will be like identified there.
Yes, it is
Means
used to identify.
means that is
Yeah.
depends upon which data actually we need to send, right? Actually, based on that. Hello.
Actually, yes, you are audible, and you.
Means
audible.
actually which data is need to be passed. Actually, based on that that protocol will be enabled, right?
Actually,
for this field.
this protocol field is for, this is IP header. IP header means at network layer there are some protocol. Can anyone tell me the name of some protocols which work at network layer? Some protocol works at network layer.
DHCP
ICMP.
Okay.
DHPC
Okay.
OSPF.
OS.
OSPF.
Advanced routing protocol like OSPF,
Okay.
AGRP.
RIP.
There are
EIRP.
two types of protocol.
RIP.
One is routed protocol and one is routing protocol. Now,
Routing
can anyone
protocol,
tell me
yes.
what is the difference between routed protocol and routing protocol? Hello? Anything. Doesn't matter you are wrong or right.
Routed protocols means with the help of established routes, the packet exchange will happen. Routing protocols is you learn the routes.
Okay, routed protocol is used to actually encapsulate the packet. Okay, can anyone tell me TCP is routed protocol or routing protocol?
Routed protocol.
Routed.
IP?
IP and TCP, these are IP also routed protocol.
Yes. IPv4, IPv6, right? So here we are talking about IPv4. This is IPv4 header. IPv4 header. So protocol field is used to identify that who have actually hand over the data to IP protocol. Actually, IP protocol is going to add this header. IP protocol, IPv4 protocol is going to add this header. So someone is going to, or some protocol is going to hand over the data to IP protocol, then only IP protocol is going to add this data, these extra information like IP header. It will attach this IP header with data. So this protocol will identify who have hand over the data to IP protocol. So here, if let's say TCP transmission control protocol have hand over one segment to IP protocol at network layer. So in the protocol field there will be protocol number of TCP. If UDP have hand over it, then there will be protocol number of UDP. What is the protocol number of TCP? Ankesh?
I don't know, sir. Protocol number.
UDP, OSPF?
So no idea about this.
Anyone don't know?
Means you're asking that administrative distance for OSPF or how?
No, protocol number like TCP have one protocol number that is 6.
Yeah, for UDP it is 17.
Yeah, for UDP it is 17. So if TCP will hand over something to IP protocol, in protocol field there will be value 6. Protocol number of TCP. If UDP have hand over something to IP protocol, there will be information about UDP. If OSPF have hand over something to IP protocol, there will be information about OSPF, protocol number of OSPF, EIGRP, ICMP. What is the protocol number of ICMP?
1.
1. So if ICMP protocol have hand over something to IP protocol, there will be information of ICMP. Okay. And what is TTL, time to live? These two fields are important, and then source IP and destination IP. You already know source IP, destination IP. Try to understand TTL now. TTL value is used to avoid layer 3 loop. It is used to avoid layer 3 loop. Guys, now I am going to design one topology here. Let's say here I have router number 1. Here I have another router 2. Then router 3, and then router number 4. We have 4 router. Don't worry about routing, you will understand routing in upcoming day. But let's say these router are connected like this, and here we have one PC, and here also we have one PC. Here IP address is 10.1.1.1 and here IP address is 20.1.1.1. See, router 1 will have information about PC1 IP address because PC1 is directly connected with router number 1, and router 1 will not have information about 20 network. So you have to tell to router 1 that where is 20 network. If you want to forward any traffic in 20 network, maybe you should forward the traffic to router number 2 or you should forward the traffic to router number 3. Okay, so let's say here I have tell to router number 1 that whenever you need to forward traffic to 20.1.1.1, 20.1.1.1, you should forward the traffic to router number 2. And I have tell to router number 2 that whenever you need to forward traffic to 20.1.1.1, you should forward the traffic to router number 1. What will happen in this scenario? Whenever this PC, when this PC will communicate with this PC, right? PC will forward traffic to router number 1. Router will check destination. Destination is 20.1.1.1. Okay, I have one entry. If destination is 20.1.1.1, I need to forward the traffic to router number 2. And router 2 will also check their table and it will came to know that okay, for 20 network I need to forward the traffic to router number 1. Again router 1 will forward the traffic to router 2, router 2 will forward the traffic to router 1. Like this, traffic will be moving between router 1 and router 2 for lifetime. Getting my point? Getting my point, guys? So loop can form in network. It is very easy. Let's say I have only two router R1 and R2. I have tell to router number 1 that whenever you need to reach in 10.1.1.1, you should forward the traffic to router number 2. And I have tell to router 2 also that whenever you need to reach in 10.1.1.1, you should forward the traffic to router number 1. Now, if any traffic router will receive with destination 10.1.1.1, that router will start forwarding that traffic to router number 2 and router 2 will start forwarding that traffic to router number 1, and it will be moving. So that's why we have TTL, because this type of loop can be created in the network because of network administrator, because of misconfiguration. In upcoming day you will see how loop can form in the topology. It is very easy. If you will run a single wrong command, loop can form in the topology. So there should be a automated method for avoiding loop in the network. That's why we have TTL value. In every packet, every IP packet will carry one TTL value. This TTL value. Okay, and TTL value depends on operating system. Like Windows operating system can use different TTL value, Linux operating system can use different TTL value. Cisco operating system is using what TTL value? 255. That means one packet can move up to 255 hop. Whenever a packet will cross the router, let's say here I have router 1 is connected with router 2, router 2 is connected with router 3, and router 3 is connected with router 4, and router 4 is connected with router number 5, and here so on. When router 1 will receive, let's say, any traffic with TTL value 10. So whenever router 1 is going to forward this traffic to other router, it will decrement TTL by 1. Here TTL value will become what? 9. Here TTL value will become what? 8. Here TTL value will become what? 7. Here TTL value will become what? 6. Here TTL value will become what? 5. And if TTL value will become 0 on any router, that router will drop the traffic. Router cannot process the traffic with TTL value 0. So now if I have again same scenario, router 1 and router 2. here I have told to router number 1 that if you want to reach 10.1.1.1, you should forward the traffic to router number 2, and I have told router number 2 that whenever you need to reach 10.1.1.1, you should forward the traffic to router number 1. And let's say router 1 have received one traffic where destination is 10.1.1.1. Router will check their table and it will forward the traffic to router number 2, and it will decrement the TTL by 1. Let's say in the packet TTL value is 255. So it will decrement TTL by 1. Here TTL value will become 254. When router 2 will forward it to router number 1, again it will decrement the TTL by 1. Here TTL value will become 253. So after some time TTL value will become 0, and automatically one router is going to drop the traffic. Getting my point?
So,
And
so
note,
suppose
yeah.
if in the network there are 5 routers and we are transferring a packet from router 1 to router 5, will suppose while router 5 transferring that packet to the next hop or next router and the TTL value is 0, will get router 1 get any notification of this, that due to the TTL
Yeah,
value is 0
router 1
the
will
packet
get
has, okay,
TTL expire
okay,
error.
okay.
Router
Which
1 will
router will
get
get,
error.
router 5 or
Router
router
1.
1?
Router 1, router 1. Router 5 will drop the traffic. Now, any
Okay.
router, whenever any router will drop the traffic due to TTL, it will send one error message to sender machine. Okay. Is it okay, guys? Any doubt? Clear?
Could you please explain about these fields, identification flags and fragmented offset one more time?
As I told you, identification flag, this field will used whenever router will perform fragmentation. Let's say router have divide one large size of data into into two fragment. So here identification value will be 1. Here also identification value will be 1. That means these two small data is a part of same data, same large data. And fragment offset list is used for sequencing. Whenever router will perform what fragmentation, like identification field and fragment offset list is used for, this is offset list is used for fragmented data. Here you can read, brother, these things. Here I have already mentioned everything. Like version, this field tell us which IP version we are using. Header length, this 4 bits value tell us the length of IP header. Type of service is used for quality of service. Total length, this field indicate that the entire size of IP packet including data and header. Identification field, if the IP packet is fragmented, then each fragmented packet will use the same 16 bits identification number to identify which IP packet they belong to. And after that there are 3 flag. These 3 flag are used in fragmentation again. First bit will be always 0. The second bit is called don't fragment. Don't fragment, if router will receive don't fragment bits on packet, and let's say size of data is more than MTU, then router will drop the data. It cannot perform the fragmentation. Don't fragment. More fragment means if this bit is on, that means more fragmented bit is coming, right? This is not the last fragmented bit. And fragment offset, this 13 bits value specify the position of original fragmented IP packet. TTL, every time an IP packet passes through a router, the time to leave field is decremented by 1. Once it hits to 0, the router will drop the packet. Protocol. This will tell us which protocol is encapsulated in IP packet. For example, TCP has value 6 and UDP has value 17. Okay. You know, there is one command, trace route. Trace route. How many of you know this command?
It will identify the number of hops in between from source to destination.
Yeah.
Yes.
If you want to learn TTL, just I am going to show you how TTL works. See if you guys, because I am asking you again and again, is it clear you guys are not speaking? So let me show you. So definitely I think you guys have some doubt in TTL. Yes or no?
Yes, yes.
Yes, na? So just wait. Is GNS3 visible? Is GNS3
Yes.
visible, guys?
Yes, yes.
Okay. Let's say this is client. Trace route is used. This is a feature which is used to trace the routers between source and destination. Let's say this is client. Don't focus on other things, just only focus on TTL. Okay, this client is connected with one router here, R1, and this R1 is connected with another router, R2. This is connected with another router, and this router is connected with another router, and let's say this is server. When we are running traceroute command, na, Cisco devices is generating one UDP packet. UDP packet with TTL value 1. First of all, I will configure the scenario. Or let's say this is server. This is not R4, this is device is on. So this client want to trace that how many routers are there between this server and client. Between server and client, how many routers are there, right? Just we want to trace route. This is one server. On server, we will configure no IP routing to disable routing on any devices. On routers, like if you want to disable the routing, or on switches, layer 3 switches, you want to disable the routing. So simply you can run no IP routing command. So on client machine and on server, I will run no IP routing command to disable routing. Let's say here we are running any IP address. Here let's say we are running IP 10.1.1.0/24 network. This is one network. IP address of machine is 10.1.1.1, and on router we will configure 10.1.1.100. Between router 1 and router 2 I am going to use 2L network, 12.1.1.0/24. Guys, in the entire course between router 1 and router 2 I will use same network, 2L network. 1 is for router 1 and 2 is for router 2. Means between router 1 and router 2 I will use 12 network. Between router 2 and router 3 I will use 23 network. In the entire course here I will always use 23 network, 0/24. After IP addressing you will understand these things, don't worry. Here I am running, let's say 20.1.1.0/24 network. Now I am going to first configure the scenario. You don't need to focus on configuration. R1 config T interface fast Ethernet 0/0 no set, and IP address is 10.1.1.1 100 255.255.255.0 exit interface F1/0 no set, and IP address is 12.1.1.1 255.255.255.0 exit router EIGRP ES number 100 network 0.0.0.0. Okay, configuration of router 1 is done. Let me configure router 2. Interface fast Ethernet 0/0 no set, and IP address over here will be 12.1.1.2 255.255.255.0 exit interface F1/0. Here I am going to say IP 23.1.1.2, let's say 255.255.255.0 exit router EIGRP ES number 100. I'm going to say network 0.0.0. Done. Router 2 configuration is done. Router 3 config T interface F0/0 no set, and IP address is 23.1.1.3 255.255.255.0 exit interface fast Ethernet 1/0 no set, and IP address is 20.1.1.100 255.255.255.0 exit, and then server, sorry, we need to configure EIGRP also. So router EIGRP case number 100, let's say network 0.0.0.0. Config T interface F0/0 no set, IP address is 20.1.1.1 255.255.255.0, and here I am going to say no IP routing, just to disable routing, and IP default gateway IP address is 20.1.1.100. Done. Let me ping the gateway IP address 20.1.1.100. Yes, I am able to ping my gateway, and finally let me configure the client machine. Interface F0/0 no set, IP address is 10.1.1.1 255.255.255.0 exit say no IP routing, no
Prabal,
yeah,
you already assigned 1.1 IP for router 1.
I think I have assigned 1.100. Do so IP interface brief 1.100, brother.
Got it.
Interface F0/0. Sorry, here also I have assigned the IP address, no IP routing, and IP default gateway 10.1.1.100. Now this client can ping server. Let me check. First of all, let me ping the gateway. Yeah, able to ping. Now I am going to ping the server. Ping 20.1.1.1. Yes, see, this client is able to ping. Now here we have one feature, we have one utility that we can use to trace route, that how many routers are there between source to destination. See, if I am running trace route and 20.1.1.1, so it is showing me that how many devices are there. First device is 10.1.1.100 means router 1, then 12.1.1.2 means router 2, then 23.1.1.3 means router 3, and then 20.1.1.1 means finally server. Getting my point? See how traceroute is working. When I am running this command traceroute 20.1.1.1, first of all this client machine will generate one UDP packet with TTL, and at layer 3 TTL value will be 1. TTL value will be 1, and source IP will be what? Source IP 10.1.1.1, and destination IP will be what? 20.1.1.1. Okay, and this client machine will forward this packet to router number 1. What will happen on router number 1? Yes, can anyone explain what will happen on router number 1? See, TTL value will become what? 0.
So
TTL value will
it will send an TTL expired.
Yes, very good. Client machine will send the UDP message with TTL value 1, and as you know TTL value will become 0 on router number 1. So router 1 will send one error message. Router 1 will send one error message. TTL expire. When client machine will receive this message, it will trace one hop. That means first hop is because in TTL, this TTL expire message, source IP will be what? 12.1.1. IP address of fast Ethernet 0/0 10.100.1.1.100. Client machine will came to know that okay, my first hop is 100.1.1.1. Now client have trace route first hop, that is 100.1.1.100. Again client machine will generate one UDP message, and this time TTL value will be 2. This time TTL value will be 2. So again it will forward to router number 1. Router number 1 will check what? Router 1, here TTL value will be 2. Router 1 will check destination because TTL value is this time what? More than 1. It will check destination. Destination is what? 20.1.1.1. Router 1 is going to check their routing table. To forward traffic to 20.1.1.1. So IP route. In the routing table, yes, there is one network available for 20.1.1.0. I need to forward traffic to 12.1.1.2. Router 1 will forward the traffic to 12.1.1.2. Exit interface is fast Ethernet 1/0. From fast Ethernet 1/0, router 1 is going to forward this packet, but it will decrement the TTL by 1. Again on router number 2, this time TTL value will become what? 0. So this time router 2 need to generate what? Error message. So this time router 2 will generate error message. Source IP will be 12.1.1.12. IP address of router 2 12.1.1.2, right? And destination will be again same, client IP address. When client will receive this message, client have trace second hop. That is 12.1.1.2. Again client will generate same UDP message with TTL value 3. This time it will set TTL value what? 3.
Praful, sorry to
Okay.
interrupt. Why this is
Yeah.
100.1.1.100?
No, actually,
Here, this
that
is the IP address of this
10.1.1.
interface. Sorry,
No, that is
it's 10.
10.
Sorry,
Yeah.
extremely sorry. This is not 100, this is 10. 10. Okay, sorry, brother. Okay.
Please.
In third message, it will set TTL value 3. And again, it will forward to router number 1. Router 1 will forward it to. It will decrement the TTL by 1. And after that, router 1 will forward the traffic to router number 2 with what? TTL value 2. Router 2 will check their routing table. In their routing table, there is one route available towards router number 3. It will again decrement the TTL by 1 and it will send the packet to router number 3. TTL will become 1 here. When router 3 will receive this packet, again here TTL value will become 0. So this time router 3 is going to generate error message. This time router 3 is going to generate error message, and in error message source IP will be the IP address of router number 3. IP address of router 3 is 23.1.1.23.1.1.3, right? And router 3 will forward this error message to router number, so to client. Destination will be 10.1.1.1. Again client will receive this error message with source 23.1.1.3. it will trace route. It will came to know that okay, third hope is 23.1.1.3. After that, again this client machine will generate one UDP message with TTL value what 4. And this time when client will send this message to router number 1 with TTL value 4. Router 1 will decrement the TTL by 1, and after that it will forward the traffic to router number 2. Here TTL value will become 3, and router 3 will forward this, router 2, and router 2 will forward this traffic to router number 3, and it will decrement the TTL by 1. And this time on router number 3 TTL value is 2.
1 1.
So router 3 will not drop the traffic. Router 3 will forward the traffic to server, and this time again server will generate now reply message. So when server will generate reply, source will be what? Source in the packet will be IP address of server. IP address of server, yes or no? 20.1.1.1. And client machine will finally, when client machine will receive this message, this is not TTL expire message. When client machine will receive this packet, it will came to know that okay, there are 3 hope. Last is 20.1.1.1, which is the server. So this is how client is able to trace route the all routers, and you can see here this is your trace route, and this is the trace route which is shown here. 10.1.1.100, 12.1.1.2, 23.1.1.3, and finally 20.1.1.1. Now what I am going to do, I am going to capture the link between client to router number 1. This is the capturing. Between router 1 to router 2 also I am going to capture the link. Between router 2 to router 3 also I am going to capture the link. And between router 3 and server also I am going to capture the link. Okay, so I have captured the link between all devices. Here is my capturing. Okay, and I want to check only, let's say, ICMP message. So here I don't have any ICMP message. Here also I want to see only ICMP message, so filter it, don't have any message. ICMP, or if you will filter the ICMP traffic, then we cannot see UDP message. So later on I will show you UDP message also. First try to see the ICMP error message. Now I am going to trace route from client machine 1, again trace route 20.1.1.1, and see in the capturing which message it is. Time to leave exceeded. If you will open it, see source is IP address of client, destination is source is IP address of router interface. Router is forwarding this message to host. Router is forwarding this message to host, and this is ICMP traffic. So TTL expire message is nothing but one ICMP message. There are lots of ICMP messages, guys. You will understand lots of ICMP messages, and we differentiate all messages with type code. Here you can see type code is 11. Type, whenever in ICMP you will see type code 11, that means it is an time to live, means TTL exceeded message. Okay, so when client machine have sent the first message, this router 1 have generate this message. Okay, after that, if you will open second message, this message source is this one, 12.1.1.2 to 10.1.1.1. This is the message which router 2 is forwarding to client machine. Again, type value is 11, and this time source IP address is 12.1.1.1, means router 2 have sent this message to client. So second packet is dropping on router number 2. Second packet have dropped on router number 2. First packet, first UDP packet have dropped on router number 1. Third packet have dropped on router number 3. And if you will check this message, router 3 is sending this message 23.1.1.3. Destination is again same, the IP address of host. Type same, code 0. We will understand type and code of ICMP later. Okay, and finally, if here we have lots of EIGRP message between routers, that's why it is difficult to find our exact message of UDP and ICMP. But here you can see this is the capturing between router 3 and server. Router 3 and server. So server have sent this message 20.1.1.1. Source means the IP address of server, and destination is client 10.1.1.1. This is also, this is not ICMP error message. Here type code is what? 3. Type code is 3, means destination unreachable. So server have sent this message. And finally, if you want to check UDP message here, UDP we don't need to capture link between all devices. We can capture the link between client and PC, and we can see the all message. See the first UDP message, source 10.1.1, destination 20.1.1.1. In first packet you can see TTL value is what? Where we can see the TTL value inside the IP header. So you will always open internet protocol field, internet protocol version 4 field, and here you can see TTL value is
1.
Okay, if you will open second packet, after that this is time to live message, this is second message, second UDP message. Again source IP and destination IP is same. Here TTL value is, this is I think same message, same packet. Yes, this is second packet. TTL value is, and you can see the protocol field inside the IP header protocol field. Why protocol number is 17 or UDP? Because as I told you that for trace route Cisco IOS use UDP protocol. So to IP protocol, who have hand over the actual data? UDP. So there is information of UDP. Is it clear how TTL works?
Sir, one doubt I have. In the real internet also, is this the same way TTL works?
Yeah, same way.
Because all these steps are not shown. Like when you type google.com ping or trace route, it shows as if they router 1 knows router 2, router 2 knows router 3. So I used to wonder how they know how many hops are there.
It will show you all hope between source and destination.
Yeah. So it is one by one. It is showing, right? First hop,
Right.
TTL, the second
Right.
hop. Okay. Okay. Understood. Now I understood. This is very informative.
Hmm. Any other question? You know, in Wireshark, you will not get exact output. That's why here we are able to see lots of messages. But always keep in mind, whenever router will receive the traffic, when router will receive the traffic, router function is rewrite the layer 2 information. Whenever R1 will receive the packet, what R1 will do, before forwarding the traffic to router number 2, router 1 will rewrite layer 2 information. It will remove the layer 2 information and it will add the new layer 2 header. So all the devices who can change the layer 2 information will always decrement TTL by 1. Not only router, all the devices who have capability to change layer 2 information. It can be firewall, it can be layer 3 switch, it can be router, right?
Yeah. Okay. Bridge also can do, right?
Right.
Bridge.
No, bridge is layer 2 device.
No, if switch can do, then bridge can also reduce it, right?
Switch is layer 3 device also, right? There are two
Yeah,
types
yeah.
of
Okay,
switch.
okay.
Layer 2 and layer 3, and again the layer 2 and layer 3 switches categorized in two parts, manageable and unmanageable.
So here only layer 3 can decrement by 1, not layer 2.
Yes,
Okay.
not layer 2.
Okay.
Any layer 3 device will decrement TTL by 1.
Like if see, in ideal world, maybe there won't be any direct connection between network to network, or I mean router to router. Suppose one router is having connected to another hubs, or I'm sorry, switches, and then from there it is going to another router. Yeah.
Okay, so forwarding of switch is completely different, right? Switch never check layer 3 information like layer 2 switch. Layer 2 switch will not open IP header. It will check only layer 2 information, and after that forward the traffic to next device.
Oh, okay. Understood.
Only layer 3 device will open IP header. Okay. And finally, guys, we have second data link layer. At data link layer, first of all, tell me, is these all field clear? This field is used for quality of service. This field will tell you the size of your header, and this field will tell you the version. Here we have information of total length. Identification is used for fragmentation. Flag is used for fragmentation. Identification field and flag and fragment. Offset is used for fragmentation. TTL is used for loop avoidance. Protocol field is used to identify, we can say, upper layer protocol, or the actual packet is encapsulated, which packet is encapsulated with IP protocol. Okay, checksum is similar like checksum field in transport layer. Don't know why, we have checksum field at every layer.
सर वन क्वेश्चन सर
हाँ
सर कैसे डिसाइड करेंगे कि कौन सा प्रोटोकॉल लगेगा नेटवर्क लेयर पर कौन सा नहीं?
ओके, अभी पता चल जाएगा वो भी. Then source IP.
In the TCP also, the checksum is there. Here also.
Yeah, I don't know what is the logic of putting checksum field at each layer.
Yeah, only it's showing that error control. Actually, how it will control error control means actually
Error
what is the function?
error detection, that is there any error in data or not, at which each layer, in the OSI model, at which each layer devices are going to check that is there any error in data or not. I think there should be only checksum field in TCP error or at layer 2, that is enough. Here checksum is not required, but still checksum field is there in IP header.
Okay.
Okay, so is these all field clear to everyone? Here also you have seen the all field. Let me show you again. I'm going to generate any packet from this client machine just to show you IP header this time. Or you can see this is message of EIGRP, hello message. If you will open this message, also we have layer 3 header, IP header. Okay, see, these all field. Version is 4, header length 20 byte, total length 60 byte, identification field 0, flags 0x00, fragment offset 0, because router have not performed fragmentation for this packet, so that's why these all bits is 0. TTL 1, protocol field EIGRP 88. Then header checksum, source IP, destination IP. This is IP header. Okay. Can I move? And then you can see layer 2 header, Ethernet header here. Ethernet header. In Ethernet header, if we will open the Ethernet header, you can see these three fields are very important. Source MAC, destination MAC. Source MAC, destination MAC, you already know source MAC will be the MAC address of sender device, destination MAC will be the MAC address of receiver device, and then type field. Type field is similar like protocol field in IP header. Here in layer 2, type field is used to identify that which protocols have hand over the actual data to Ethernet header to data link layer. Okay. Now if I have two computer, let's say I have two computer, both are directly connected with each other. MAC address of computer A is, let's say, 0A. MAC address of computer B is, let's say, 0B. Here IP address is, let's say, 10.1.1.1, and IP address of machine 2 is, let's say, 10.1.1.2. Can anyone explain the packet flow between PC1 and PC2? What will happen when I will type, when I will open CMD on PC1 and I will type ping 10.1.1.2? What will happen on PC number 1? When I will type this in CMD, what this machine will do?
It will check in the routing table and then the MAC table.
First of all, this machine will generate any packet, na?
It will generate ICMP packet. It will ICMP
echo request will generate.
So it will add this type, that is 8, and then the protocol number 1, and then this ICMP request will be encapsulated in IP datagram. So there it will add this source IP, that will be the 10.1, and the destination IP will be 10.2, and TTL value, and the type will be 0x0800. and then it will come to the L2. In the L2, it will add the source MAC, and in the and destination MAC. So since destination MAC it is not available, then it will generate the ARP request.
Okay. Anything else? Any other explanation?
It will generate that echo request message first. Okay.
Okay. How to identify echo request and reply?
That ICMP packet only.
In ICMP packet, what information will be there? How to identify that it is an echo request or reply? You are saying that, okay, you are saying that this machine will generate one ICMP request. Okay. Okay, let's say it have generated one ICMP request. Done. After that, it will hand over to IP protocol. Am I right?
Yes, yes.
IP protocol will add IP protocol will do what? It will add IP header. In the IP header, there will be source IP address 10.1.1. There will be destination IP address 10.1.1.2. Okay.
Yeah.
Then there will be protocol field. In protocol field, value will be
Set. Okay.
1.
Yeah.
Protocol number of ICMP. Then IP protocol will hand over it to lower layer, data link layer.
Yes.
Data link layer will add source MAC address 0A, destination MAC address
Yes.
0B. Let's say it will check their the destination MAC address in ARP table. Let's say PC1 have information about the MAC address of 10.1.1.2. Okay. Then there will be type field. In type field, what will be the value?
0x0800 for Ethernet.
0x0800. Why?
How it will select this one?
Oh, this is for like IP.
This is type code of IPv4.
Yeah, IPv4. Yes.
IPv4. Okay.
Right, means who have hand over data link layer, means at data link layer actually can anyone tell me which protocol is working? Like here
Ethernet.
at network layer IP protocol is working. At layer 2 which protocol is working? Ethernet is an technology, not a protocol.
ARP protocol.
Yeah. ARP.
ARP is used to find MAC address from IP address.
MAC.
ARPA protocol is responsible to encapsulate frame. Like IP protocol is responsible to encapsulate packet, ARPA protocol is responsible to encapsulate frame. Okay, let's say after that it will hand over to physical layer, and physical layer will forward this to PC2. Okay, fine, agree. When PC2 will receive this, first of all PC2 will receive this at which layer? At physical layer, right?
Yes.
At physical layer. At physical layer it will check. At physical layer, okay, at physical layer it will convert the signal into bits, and after that it will hand over to
Data link layer.
data link layer. Data link layer will check first destination MAC address. So destination MAC address is 0B.
0B. Yeah.
0B. Okay. So destination MAC address is the MAC address of PC.
Yeah. Here in
It
the
will
data link
accept the
layer.
packet.
Yeah. That point-to-point protocol we have to use, right? The data link layer.
At data link layer,
Point-to-point
ARPA protocol.
No, that protocol which we have to use, like frame relay, point-to-point. Actually, these are the protocols, right? In the data link layer.
So that is Ethernet.
Yeah,
Ethernet 2.
Yeah. Okay.
Here PC first will check, PC2 will check destination MAC. Okay, MAC, if MAC address is the MAC address of PC2, then only it will accept it. After that, PC2 have to check type field. In type field, because there is information that I need to hand over this to which protocol at network layer, because at network layer there are many protocol. So here in the type field there is information that this is the type code of IPv4. Data link layer will came to know that I need to remove this. I need to remove this information, layer 2 information, and I need to hand over it to IP protocol. IP protocol will check destination IP. Okay, that is fine. 10.1.1.2 is the my IP address. Let me check protocol field. Oh, protocol field. Protocol value is 1. That means I need to hand over actual data to
IP.
Actual data to ICMP, na? This is
Yeah.
protocol number of ICMP.
Yeah.
So it will hand over the actual ICMP, actual traffic to ICMP. Now how ICMP is came to know that this is request or reply? Which type of message it is? Because there are many type of messages. As I show you in previous example, type code 11 ICMP used for TTL expire.
Yes. I think ICMP, that is one only, right? Echo request.
Yeah, there is type code for each type of for ICMP message type. There are multiple types of ICMP message. So when we are running command ping isn't just a utility which uses ICMP protocol. So when you are typing ping 10.1.1.2, actually ICMP protocol will generate one ICMP echo request message. And what is the type code of echo request message? 8.
Okay, 8. Okay.
Packet flow is very important, I must tell you, for troubleshooting also and to understand advanced concept of routing and switching also. One minute. Configure one IP address. Let's say here I am going to configure IP 10.1.1.1 and here I am going to configure IP 10.1.1.2. Okay, I'm going to capture the link as well between PC1 and PC2 and let me access this two device. See, I am going to show you some information here and those are very important. Fast Ethernet 0/0 no shutdown and IP address is 10.1.1.1 255.255.255.0 and no IP routing. Okay, so IP interface brief. Guys, I have configured one IP address over here. Whenever you will configure IP address to any machine, first thing that machine will do is that machine will start maintaining a table called which table?
ARP table.
ARP table. So command to check ARP table on Cisco IOS is show IP ARP. See, in Cisco IS, you will see there will be their own IP address and on MAC address. In Windows operating system, machine will store only remote devices information, not their own information. Okay, but here we are able to see the IP address of PC1 and the MAC address of PC1. Okay, and for the communication between PC1 and PC2, both computers should have knowledge about the IP address of each other and MAC address of each other. Agree?
Yes.
Right? Until and unless PC1 don't know what is the MAC address of PC2, it cannot forward any traffic. Okay? So I am going to configure only IP address on PC number 2, and you will see one thing. Interface F0/0, here say no cert, and IP address 10.1.1.2 255.255.255.0, and no IP routing, no IP routing. Done. On PC1, sorry, I have configured, I think,
Yeah,
10.2 on PC2.
same IP addresses only. You configure the same IP addresses in the both PCs.
On PC1, IP address should be IP address 10.1.1.1 255.255.255.0. See, I am getting one error, duplicate IP address.
Yes.
How can anyone tell me how PC1 have came to know that this is duplicate IP address? How PC1 have came to know that this is a duplicate IP address? Because it is giving me error that it is a duplicate IP address on fast Ethernet 0/0.
Because
And
it
same
will
error,
check
using
the
GR
ARP
packet.
table, right?
GR. Whenever you will configure IP address, first of all, device will start maintaining a table called ARP table, and before maintaining that table, device will check that this IP address is unique or not. This IP address is unique or not. Is it duplicate IP address or not? For that, first of all, client machine will send Gracious ARP, GARP. What is the use of GARP? Just to check duplicate IP address. When I have configured IP address 10.1.1.1 on router on PC number 1, first PC1 is going to broadcast one message. If you want to check that message, here I can show you. Are you able to see Gracious ARP message? Gracious ARP. If you will open the Gracious ARP message, you can see here, this is the message, Gracious ARP message. If I will open this message, there is nothing, right? But this is the actual Gracious ARP message. This is not, this is the error message. Here is the Gracious ARP message. If you will open Gracious ARP message, see, source IP is what? 10.1.1.1. Target IP address is what? Same, 10.1.1.1. If you are assigning a IP address to machine 10.1.1.1, machine is going to generate one Gracious ARP message where source and destination both will be same. And at layer 2 it is broadcast message. At layer 2 it is broadcast message. Means it is going to forward this message to all PC in LAN. Now who will generate reply to Gracious ARP? The machine who is using same IP address. Yes or no? Brother, if PC1 is generating one message where source is 10.1.1.1 and destination is 10.1.1.1, and let's say there are 100 computer connected in same network, right? Source is, let's say, MAC address of PC1 0A and destination MAC is OLAF. OLAF means broadcast. So this message will be received by all devices in the LAN. PC2 will also receive this message. Will PC2 generate reply? PC2 will generate reply only in one scenario, if PC2 is using same IP address. Yes or no?
Yes, yes.
Right? So after generating Gracious ARP, this PC will wait for 2 seconds. Within 2 seconds, if this machine will get reply message, it will give you error that this IP address is duplicate. Or in 2 seconds, if this machine will not receive any message, then it will assign that IP address from on their interface. Is it clear? Is it clear to all?
Yes, yes.
Whenever we will configure IP address, first of all, machine will check that IP address is unique or not. If how it is going to find, with the help of Gracious ARP. In Gracious ARP, source IP will be the IP address of sender machine. Target IP address will be also the IP address of sender machine, and at layer 2 it will be broadcast. At layer 2, it will be broadcast. So only machine who is using that IP address will generate reply. Within 2 seconds, if machine will get reply, it will give you duplicate IP address error. If it will not receive any reply, it will assign that IP address. Done. This is the first step of packet flow. And are you able to see any layer 3 information here? No. Why there is no layer 3 information, guys? IP header. Because this protocol works at layer 2. Layer 2. So you can see machine will generate this ARP, gracious ARP message at layer 2. At layer 2. Okay. After that, here I am going to correct it. Correct the IP address. Let me correct the IP address on PC2. Config T interface F0/0 IP address is 10.1.1.2 255.255.255.0. Done. So IP ARP. Okay, this is the IP address of computer 2 and this is the MAC address of computer 2, computer A. So IP ARP. Done. Both have their own MAC address, their own IP address in ARP table, right? Now PC1 don't know what is the MAC address of PC2 and PC2 don't know what is the MAC address of PC1. First of all, one thing I want to show you. So interface fast Ethernet 0/0. Guys, here encapsulation protocol like layer 2 encapsulation protocol is it visible? ARPA?
Yes, yes.
So like at layer 3, IP protocol is encapsulating the packet, or IPv6 protocol is encapsulating the packet, or any other protocol is encapsulating the packet. At layer 2, ARPA protocol is encapsulating the frame on Ethernet link. On Ethernet link. Encapsulating, this is interview question, I must tell you. Interviewer can ask you, what is the encapsulation protocol at layer 2 in the case of Ethernet? So ARPA protocol. Done. Now I am going to ping PC1 to PC2. Here is the capturing. Okay, in the PC1 I am going to run command ping 10.1.2.1. see what will happen when I will hit enter. When I will hit enter, it will generate one ICMP request message, right? This PC will generate one ICMP request message, definitely request message. After that, ICMP protocol will hand over that ICMP request message to IP protocol, and responsibility of IP protocol is to add IP header. Just you have learned it, right? IP header. So in IP header there is source IP address 10.1.1.1 and there is destination IP address 10.1.1.2. after that there is protocol field. Only these three field is important to understand packet flow: source IP, destination IP and protocol. So in the protocol field there will be information about the protocol who hand over this to IP protocol. So ICMP have hand over the actual data to IP protocol, so there will be protocol number of ICMP, and protocol number of ICMP is 1. After that, IP protocol will hand over it to layer 2. Now responsibility of layer 2 is to provide source MAC and destination MAC, as you already know. So here this PC is going to provide source MAC address. Source MAC address is the MAC address of PC1. Let me check what is the MAC address of PC1. So interface F0/0 and say include, we can say by yes, this is the MAC address of PC1. So it will put this MAC address as a source MAC address. Now ARPA protocol need what? ARPA protocol need destination MAC address. So to find the destination MAC address, it will check ARP table. So IP ARP. Oops. MAC address of 10.1.1.2 is not available. Yes or no? So this is problem, because until and unless this PC will not encapsulate the frame, it cannot forward the frame to next layer, to physical layer. Here frame is pending because of destination MAC address. This machine don't have destination MAC address. So it will put, ARPA protocol will put this information on hold. It will put this information on hold, and it is going to call one protocol. Hey ARP, come here. It will, ARPA protocol will call to ARP protocol, ARP protocol, and ARP protocol is used to find MAC address from IP address. The use of ARP protocol is only to find MAC address from IP address. So ARPA protocol will tell to ARP protocol, please find the MAC address of 10.1.1.2. ARP protocol will do nothing. ARP protocol will generate one ARP request. It will generate one ARP request message. Inside the ARP request message, there will be source IP address. Source IP address will be 10.1.1.1 and target IP address will be, this is not IP header, must tell you. This is the information inside ARP request. ARP is again layer 2 protocol, not layer 3 protocol. So in ARP message there is information of source IP address and target IP address will be 10.1.1.2. And at layer 2 source MAC will be the MAC address of this PC, whatever MAC address is PC1 MAC address, and destination MAC address will be broadcast, means this PC is going to forward this packet to all computer in LAN, right? This is how our protocol is going to find MAC address. So if you want to see our packet, so let me ping over here, because see, this machine don't have information about the MAC address of 10.1.1.2. Ping 10.1.2.1. First packet is our packet. See, who is 10.1.2.1? Who is 10.1.2.1 till to 10.1.1.1, and it is not able to resolve ARP. ICMP success rate is 0%. There is some misconfiguration as well. PC1 is not able to find what is the MAC address of PC2. It is trying, you can see still trying, it is still sending ARP request message. Who is 10.1.2.1 till to 10.1.1.1.
Sorry to interrupt. Why it is 10.1.2.1?
Because here you can see we have type what?
No, but the destination IP should be 10.1.1.2, right?
But I have typed different IP address. If you, I will type 10.1.1.100, it will start finding the MAC address of 10.1.1.100. Yes or no? It will start finding the MAC address of this IP address. Yes or no?
Yes.
So PC1 is not able to find the MAC address of 10.1.2.1. So finally what this PC will do, it will drop this ICMP, actual ICMP packet also. Okay.
Okay, got it. Yeah.
Got it. And if I will ping which IP address, 10.1.1.2, this time you can see here. First it have generated the ARP request PC1. So who is 10.1.1.2 till to 10.1.1.1, and 10.1.1.2 have generated one reply message. Here is the reply message. Where is reply message? First of all, let me show you ICMP, ARP request message. There is some problem. Let me repeat the process once again. But here on PC number 1, if you will check ARP table now, so IP ARP. In ARP table now we have two entry. This is the MAC address of 10.1.1.1 and this is the MAC address of 10.1.2.1. Okay, again I am going to clear IP ARP, clear IP ARP and 10.1.1.2 and show IP ARP. Okay, and in PC2 show IP ARP, clear IP ARP 10.1.1.1 and show IP ARP. Okay, now again I am going to generate ICMP packet ping 10.1.1.2. IP address of this machine is show IP interface brief 10.1.1.1, right? Ping 10.1.1.2. Ping is working, and let me check here. In Wireshark, this is error of Wireshark only. This is error of Wireshark. Let me close it. Or it will be better if we will discuss, if we will continue from here to tomorrow. Okay, so I will continue same process tomorrow. And packet flow is very important. After discussing packet flow, we will start IPv4 addressing. Okay guys, if anyone have any doubt, you can ask me now. There was some error in Wireshark, that's why we were not able to see actual output. That's why I have closed the session. Okay.